Hi guys, welcome back. So today we're going to be working on a problem that has come up quite frequently in our tests. So let me just write this out. So we're going to be doing integrals again. I promise we'll focus on a different topic, but I do think that this is quite important because I've seen this come up quite often. So the integral of e to the 2x times sine of x. So I think by looking at this problem, one should be able to see that it's an integration by parts problem because there's two functions being multiplied together and you take the integral of that. So I think that people should learn to recognize that. So now that we've established that this is an integration by parts problem, we can use Lie8. So I taught this in the last video. This is a really useful abbreviation. So Lie8. Lie8 stands for logarithmic functions, inverse functions, algebraic functions, trigonometric functions, and exponential functions. So in essence, this tells you the order to differentiate functions. So logarithmic being the first function you should differentiate, and exponential function being the last function you should differentiate. Everything in between just being in between. So in this instance, when we apply Lie8 to this problem, we can see that the trigonometric function outweighs the exponential function here. The trigonometric function is sine of x, and the exponential function is e to the power 2x. So what we can do, we can say that u is equal to sine of x, and dv equals e to the 2x dx. So we followed through the standard procedure, which is that du, which is taking the derivative of the integral of these. So du is equal to sine of x cosine of x dx. V equals to e to the 2x divided by 2, because this is just basically anti-differentiation, which means that you would take a half, which means that you would divide by half rather than multiplying by half. And after this, it's just a matter of using the formula correctly. So the formula obviously states that the integral of u, I should draw my u's out a bit better, right? U dv equals to u v minus the integral of v du. I'll just draw that du a bit better. There you go. So this is the formula. So it's just a matter of substitution at this point. Let me create another layer. Okay. Let me use a different color. Let me use something a bit brighter. It's orange. Seems nice. So yeah, that seems nice. So the integral of e to 2x sine of x, we've already established that u is equal to sine of x, dv equals to e to 2x dx, du is cosine of x dx, v is equal to a half e to the 2x. So again, the formula, say u times v, so sine e to 2x times sine of x divided by 2, that's u times v, that's that term, and then we're subtracting this by the integral of du times v, which is a half of okay, so let me just say this is equal to, so half of cosine of x times e to the 2x dx. So it seems like we've come to another part of the problem where we have two functions being multiplied to each other, and it seems like we can use integration by parts again. And if you thought that, well, trust your intuition and just go with it. because that's exactly what you have to do. And even if you didn't think that, I hope that you get the intuition from this now. So what we're going to focus on is we're going to change the variables, and so we can use light in it's essentially the exact same way as we used it up over here, because there's still only a trigonometric and an exponential function. So we can again say that u is equal to cosine of x dv equals e to the 2x. So I'm evaluating this integral separately. Let me actually use a different color so that I don't confuse different things. So evaluating this integral separately. So let me just say that the integral cosine of x is e to 2x dx equals to, again, u is equal to cosine of x dv equals e to 2x dx du is equal to negative sine of x dx, and v is equal to, again, a half e to the 2x. So it's basically doing the exact same thing. So it's going to be u times v. So it's going to be cosine of x, half of cosine of x times e to the 2x, minus the integral of du, which is going to be negative sine of x. But hold on, we see a negative, and then we see a negative over here, and we see a negative over here. So we can just cancel those out and say that this is plus the integral of sine of x times, we just put the half out here, e to 2x dx, because yeah, that's what's happening here. It's du times v, which is sine of x dx times a half e to the 2x, negative sine of x. So we can immediately notice something going on here. We can notice that there's a sine of x over here, so this belongs to this part. We can also see that there's this we can also see that there's the exact same integral up here. So since we have basically the two exact same integrals, what we can do is bring them all to the same side, and yeah, that's just a trick of evaluating this integral. So let's write this on a new page. It's a matter of substitution again. So we're going to have, let me just put e to 2x out here, sine of x dx is equal to e to the 2x sine of x over 2 minus e to the 2x cosine of x over 4, because we're multiplying this integral, which is in essence this, by this negative a half that's in front, this negative half coefficient. So that means that this is going to be negative 1 over 4, and this is going to be negative 1 over 4 as well. Integral of sine of x e to the 2x dx. So what we can do is, since I mentioned before, we have 2 sine of x times e to the 2x dx terms, so the integral of both terms. So if I just bring this to the other side, I can in essence say that this integral is e to the 2x sine of x dx plus a quarter of the same integral, and that is equal to e to the 2x sine of x over 2 minus e to the 2x cosine of x. I went over screen. Let me just write this really small. E to 2x cosine 4x, sorry, cosine of x cosine of x over 4. So I can simplify this integral again because this is in essence saying 4 over 4. So 4 over 4 plus 1 over 4 is going to be 5 over 4. 5 over 4 of, let me just say that this integral is just f of x. Integral of f of x dx, because it's taking too long to write. So the integral of f of x dx equals to this business over here on the right hand side. Now what we can do is just multiply both sides. Also this plus c. We can multiply both sides by 4 or 5 to get this to be 1. So we can just do that really quickly. If we just say times 0.8, which is 4 over 5. Ooh. What's going on? Yep. 0.8. We're going to have the integral of f of x. Wait, this is not showing up on the screen. Have the integral f of x dx as 4 times e to 2x sine of x over 10 minus e to the 2x is 4 e to the 2x cosine of x over 20, and this is plus c. So if we just simplify this really quickly, so this is going to be 2 times 2, 2 over 5, so this is going to be 2e to the 2x sine of x over 5 minus e to the 2x cosine of x over 5 plus c. So this, once again, to remind us, is the integral of e to the 2x sine of x dx. So there you have it. There is how you evaluate this integral. I do hope it's been helpful to follow through this process. Let me know if you have any other questions, and thanks for watching. See you guys.